Hey, welcome back to my YouTube channel. I am Xavier Smith, and today I'm going to talk about stoichiometry. So let's get into it with, first of all, recapping what a mole is. I made a video on moles, but a mole is 6.02 times 10 to the 23rd molecules, or of anything. So it's just a measurement, like we say a dozen is 12, a mole is 6.02 times 10 to the 23rd. It is an absurdly large number. It's just so big. But all it really means for us is that when we look at our periodic table, a mole of any element, like a mole of oxygen, the little mass number it says there's 15.999. Just say 15.999 grams is a mole of oxygen. Okay, so that's all you really need from a mole. And then these little ratios, like 1 mole of calcium per 2 moles of nitrate. Okay, and then there's one in nitrate, there's 1 mole of nitrogen per 3 moles of oxygen. So it's just how we do ratios here. You can't do ratios in grams. You have to convert things to moles and then see their ratios in these little formulas and then turn it back to grams. Okay, so if we find the mass of 9.03 moles of hydrogen sulfate or hydrosulfuric acid. So hydrogen, 2 hydrogens would be 1.008, would be 2.016 grams, plus the thing of sulfur is 32.06 grams per mole, and there's 1 mole of hydrogen, 2 moles of hydrogen, 1 mole of sulfur. So if we add these, 32.06 plus 2.016, we would get 34.076 grams. Oh, sorry, not done. That's grams per mole. Now we'd say, okay, well, we want grams. So we'd say, okay, 34.076 grams per mole times 9.03 moles, right? Moles would cancel. You multiply that by 9.03 and you'd get 307.70628 grams. And then if you were to do sig figs, I guess you could put it back to that. It should be like, nah, I'm not going to do sig figs yet. Okay, 307.706 grams. Something like that. Okay, now calculate the molar mass of calcium nitrate. Well, first of all, calcium is 40.078 grams per mole. There's 1 mole of that. Nitrate, well, I'm going to just do this individually. Nitrogen, there's 2 moles of that. So 1 mole of nitrogen would be 14.007. But we have 2 of them, so multiply that by 2. And we have 28.014. And then there's going to be 6 moles of oxygen. So oxygen is 15.999 grams per mole. Multiply that by 6. We get 95.994 grams. If we add these all together, plus 28.014 plus 40.078, we would get something like 164.086 grams. So if you were told to measure get 1 mole of calcium nitrate out, you would measure 164.086 grams of calcium nitrate, and then you have 1 mole. And again, molar ratios are they're ratios. They're good throughout all the elements, all the compounds. Okay, find the mass percent of each element in NaHCO3. So you're like, what the heck? Well, we can find the mass of this and the mass of all its individual parts, and then take, okay, this is the mass of the part divided by the mass of the whole, and it'll give you the percent that the mass is of the whole, right? Now it's not so hard. So sodium is, let's check, 22.99 grams per mole. Okay, then hydrogen is 1.008 grams per mole. Then carbon is 12.011 grams per mole. I'm just getting all this from my periodic table. And then oxygen, which is O3, oxygen is 15.999 grams per mole. Now to find like the mass of this molar mass, we would add 22.99 plus 1.008, because there's one hydrogen, one sodium, plus 12.011, and then plus 3 times 15.999, and that would give us 84. That doesn't look like an 8. 84.006. So to find the total of this, we do 22.99 divided by 84.006. That would give us like roughly 27.37%. And then we do the same thing. So we do 1.008 divided by 84.006. That would give us roughly 1.2%. And this is just by mass. So you're like, well, there's one hydrogen and there's one sodium. So how is the sodium 27%, but the hydrogen is only 1%? Well, it's because hydrogen is like a 12th of the weight of, nope, it's like a 24th. It's like a 22nd of the weight of sodium. So sodium is going to be like 22 times as much of the total mass. Okay, now keep going because we got more examples to go. 12.011 divided by 84.006 give us 14.3%. And then 15.999 times 3, because there's 3 of them in there, divided by the whole, 84.009, equals 57.13%. And then if you want to add those all together, you should get something. Clearly, I see the ends of these will add up to 1. So you should get, no, they won't. Whatever. It's just rounding. It should be very close to 100. And that is how you do that problem. Okay, now going on to actually complicated ones. I'm sorry if the last one was complicated and I kind of just like threw that at you. Okay, 36.5% sodium, 25.4% sulfur, and 38.1% oxygen. Now find the empirical formula. An empirical formula is like the simplest ratio of the elements. And basically what we're saying here is there's a compound and 36.5% of it's sodium and so on. What you could do is assume any size sample, because the percent doesn't matter, just a ratio on what size sample you assume. But if you assume an 100-gram sample, this 36.5% just turns into 36.5 grams. So we have 36.5 grams sodium, then 25.4 grams sulfur, and 38.1 grams oxygen. Right? Now, again, we can't do anything with grams here. We have to convert them all into moles, where we can actually compare ratios of moles. So we have to multiply them by their molar mass. So sodium has a molar mass, as we've stated, of 22.990 grams per mole. Right? Sulfur has a molar mass of 32.06 grams per mole. And oxygen has 15.999 grams per mole. So this will give us 36.5 times 22. Wait. Never mind. We have to put the moles on top. So you just switch these. You say 1 mole of this. Yeah, so you'd say like 1 mole of sulfur is 22.990. So you're really multiplying, you're dividing. So 36.5 divided by 22.99 would give us 1.5876. Let it run out. Then 25.4 divided by 32.06 would give us 0.7922. And the reason we have to divide is because, like, if we're turning grams into moles, you have to put like mole over grams, because you're multiplying grams by that, to get rid of these grams. What I did here is made it so it's grams squared over mole. That doesn't mean anything, right? You can't compare those. You have to have mole, like you just turn it into mole, get rid of grams. So you put grams on the bottom, right? So that means you should have less moles than you have grams. If you have something like 9 moles of something and you get like 8 grams, you're probably wrong because not even hydrogen can do that. Okay, so now 38.1 divided by 15.999 would give us like 2.381. So we have these arbitrary numbers, and you're not going to say like, oh, 7, well, S to the like 0.7922 instead of like just sulfur 2 or something, like 2 sulfurs. You are going to divide by the lowest one, meaning that the lowest amount of any of these elements you can have that like comprise the compound is 1. You can have 1 atom of it per like molecule. So you have to divide the smallest one by itself and you'll get 1. So if we divide all of these divided by 0.7922, we can just see what we'll get. 1.5876 divided by 0.7922. Well, that would be 2.004. That would be 1. And that would be 2.381 divided by 0.7922 gives us 3.005. Now, you can round these. Even if it's like 2.89, you can still round that to 3, right? But if you have something like 2.49, that is wrong. You have to just double all of them. Just get rid of that. But here, we clearly have a 2 to 1 to 3 ratio. So there's 2 sodiums, right? There's 1 sulfur, and there's 3 oxygens. So our empirical formula here is Na2SO3 sodium sulfate. And it is an empirical formula because we can't simplify anything. Okay, so this is our empirical formula. That took a while, right? But now let's do one that might take longer. Maybe since you know this, it won't take longer. Again, assume in a 100-gram sample, just 85.7% turns into 85.7 grams of carbon, and this 14.3% turns into 14.3 grams of hydrogen, right? Then we can just turn it into their molar mass to see how many moles we really have, kind of, something like that. So now the molar mass of carbon, again, is 12. Oh my gosh. Again, we need to do mole over grams. So 1 mole of carbon is 12.011 grams, right? So clearly the grams would cancel. And yeah, hydrogen, we can do that. 1 mole is 1.008 grams. So that would give us, 85.7 divided by 12.011 gives us 7.135 moles of carbon, right? And then we would have 14.3 divided by 1.008 would give us 14.1865 moles of H. Again, you want to divide by the smaller number. I know you're like, this is a 7 to 14 ratio. That's 1 to 2. I know you can do it in your head. Just divide by the small one and say it's 1 to 2. Don't say it's a 7 to 14 ratio. That's not an empirical formula. All we want right now is an empirical formula, the simplest, like, whole number ratio. That's why we try to get a 1 down there, because that's usually in the simplest whole number ratio. Okay, so if we divide these both, like divide by 7.135, all you really need to do is take this one, divide by 7.135, and you get 1.998. So that is 1 mole carbon, and that is 1.988 mole H. So that's a 1 to 2 ratio, right? So the empirical, I'm going to call it the EMP form, because I'm I'm cool like that, the slang, the backwards hat. You got it all. So this is like 1 carbon per 2 hydrogens. So this is CH2, right? Now, this is the empirical formula. We're told to find the molecular formula. So for a molecular formula, we're given how much this thing weighs. This thing weighs, where does it weigh? Oh, it's right here, is 28 grams. So the molecular formula is supposed to weigh 28 grams. So we can find out how much this weighs, and then if it weighs half, we can double it. If it weighs a third, triple it, right? Or just keep multiplying it by like 2 and then 4, and finally you'll get there. If this is the right empirical formula, you will get this number after some time. So first, find this molar mass. CH2 would be carbon 12.011 plus 2 times 1.008, I believe. That'll give us 14.027 grams per mole. And clearly, you can see it's 28 we're supposed to be at, so it's a double. So you just double both of these. C2H4, I guess roughly 28 grams per mole. So C2H4 is the molecular formula of the compound. If you have any questions, please comment down below. I really appreciate when people like comment, say hi, because it's lonely over here, Well, please like and subscribe if it was helpful, and I hope I see you in the comments or back again soon. Thanks.